Hi, here we have another question from Iran Mathematical Olympiad, round number 1, year 1998. So the question says we have a set A that is 1, 2 till 1001, and we want to select a subset S from A, and this subset S has the following properties. If you take two different elements from S and you add them together, the result should not be another element of S. The question is, what is the maximum possible size of subset S? So the first round of Iranian Mathematical Olympiad usually consists of multiple choice questions. You have around 30 questions for 3 hours. Each question is on average 6 minutes. So maybe I spend 5 to 10 minutes, try to solve this exercise, and then come back and see the solution. Normally in the multiple choice questions, if you answer correct, you get plus 3 points. If you answer wrong, you get minus 1 point. So you must select the answer correctly. Okay, so we have the set A. We want to select the subset with these properties. Let's assume that subset S has a number of elements and one of them will be the largest. We call that largest element as M. Now, from 1, 2 till M, we are going to categorize this group of numbers in such a way to help us find the maximum size of S. So assume that M is an odd number. So we say 1 and M minus 1, we put them in one category. 2 and M minus 2, we put them in another category, and so on. Since we assume that M is odd, we go further, we reach to M minus 1 divided by 2, and then the other one would be M plus 1 divided by 2. So if you see the numbers, we have 1, 2, 3 till M minus 1 divided by 2, and then the next one is M plus 1 divided by 2, and then it goes up till M minus 1, and the final number is M itself. So every possible number that can be in subset S, because it can have from 1 till M, because M is the maximum, we have grouped them like this. So obviously we cannot have both of these elements at the same time in the subset S, because if we add them together, it gives us M, and since M already exists in the subset, this violates the properties of S. So from all of these, we can only select half of them, basically these, for example, numbers. So if you want to find the maximum size of S, that is very easy. The size of S is limited to M minus 1 divided by 2, because from all of these, we can select only half of it, which would be M minus 1 divided by 2. And then we have M itself, which is 1. So the size of S is bounded to this value. Because we assume M is odd, and the maximum possible odd number that we can select from set A is 1001. So if I put it here, 1001 minus 1 divided by 2 plus 1, this gives us 501. So if M is an odd number, we know that the maximum size of S is 501. Now let's see what happens if M is an even number. Same way, we categorize like this: 1, M minus 1, 2, M minus 2. We go further because this is even now. So we reach to around the middle point, M divided by 2 minus 1, and M divided by 2 plus 1, and then at the middle point, M divided by 2. Okay, so again, from all of these groups of 2, we can only select one of them and put them in S, because otherwise we add them together, the value becomes M, which is contradiction. Okay, so the maximum size of S can be obtained. It will be M divided by 2 minus 1, so half of these basically. And then we have M divided by 2, 1, and then another M, 1. Okay, so the size of S is limited to this. And the maximum even number in the set A is 1000, so we can put it here. 1000 divided by 2 minus 1 plus 1 plus 1 becomes 501. So we have shown that the maximum size of S is 501. But in order to make 100% sure that this maximum is possible, we have to give an example. And the example is very simple. You can select S equal to 501, 502 till 1001. And obviously, if you take any two number from this subset, the addition will be more than the maximum. Therefore, it fulfills the properties of S. Therefore, the maximum size of S is 501. So the answer is option C. Let's see what we have learned. In certain problems, you have to basically categorize the numbers, the elements that you have into smaller groups, and then demonstrate that only a part of each group can be included in the final solution. And based on this, you can, for example, define the boundary of the solutions or define which type of elements can be in that final solution. All right, so this is the end of the video. See you next time. Bye.